Okay, time for section 4.4. So this is another one about logs. So working with some log stuff. So one of the things that we talk about is we don't generally like write log base 10 of x, okay? This is what's called common log, and so it is just written log x. Now, this log part here that doesn't have the base on it, it's an understood base of 10. This is also the log button that's on your calculator. So if you see the log button, that is the one that is on your calculator, okay? So if we were going to do something like log of 1,000 on our calculator, okay, we would simply do log of 1,000, close that log up and press enter, and we get that that is 3. Okay, we can do stuff like log 42, and we get 1.623 roughly. Okay, and we can do log of even decimal numbers, 0.05832. And this one comes out to be negative 2.234. Okay. Now, on stuff like this, if your log base is bigger than 1, so think about that, that was the graphs that did like this, okay? If you do decimal numbers, you're going to get negative answers because that's going to push it down below the x-axis, okay? Now, one of the applications where we use common log is your pH scale, okay? So the pH of something is negative log of the hydronium ion concentrate, okay? I'm sure some of y'all know about that better than I do, okay? So now what we know is things like pure water has a pH of 7, which is neutral right there in the middle, okay? If you go higher than 7, then you are alkaline. And if you go lower than 7, you are acidic. Okay? And usually we do nearest 10th when we do these. Okay? So we're going to be talking about 1 decimal place. So they ask us, I'm going to keep our formula up here, okay, to find the pH of something if H3O positive, so our hydronium ion, is 2.5 times 10 to the negative 4. Okay, y'all, let's talk about that 10 to the negative 4. That means we are at 2.5 and we got to back up 1, 2, 3, 4 spots. Okay, so this is now what we're going to be putting on our calculator. So we're going to do negative log of 0.00025. So negative, again, I'm using my negative button down here in the bottom, log 0.00025, close that up, and I get that is going to be 3.6, again, nearest 10th when they did that. Okay, good, cool. Okay, now then, they ask us on this next one to find the hydronium ion concentration if something has a pH of 7.1. Okay, now guys, the way we're going to do this is where we are going to need to switch from exponential to log, or from log to exponential. So first off, I'm going to divide the negative under. Okay. And then we're going to loop through. Keep in mind that base is 10. Okay, so now we're just going to put 10 to the negative 7.1 on our calculator. And guys, the calculator will come up with kind of that scientific notation for us. Okay. So we're going to go 1 decimal place again. So I've got 7.9 times 10 to the negative 8. Okay. Now keep in mind, guys, that E symbol right there, that capital E symbol, it's not a lowercase e, it's not Euler's thing. That capital E right there, that is your times 10 to the notation. Okay. So keeping all that loveliness in mind. Okay. Now, one of the things, again, kind of in this same application that we have is they talk about wetlands. Okay. And within wetlands, we have bogs, fens, marshes, and swamps. Okay. Now, if we have a pH that is from 6.0 to 7.5, okay, then it's what's called a rich fen. If we have a pH between 3.0 and 6.0, then it's called a poor fen. And if it's below a pH of 3, then it's called a bog. Okay, which means our marshes and our swamps must be higher than the 7.5. And I'm sure they have classifications and ranges for all of those. So they ask the question, okay, if we have an H3O positive hydronium ion concentrate of 6.3 times 10 to the negative 5, how would we classify that? Okay, so now keeping in mind, I'm going to come over here, 6.3, and I'm going to go 1, 2, 3, 4, 5. There's my decimal place. Okay, so we're doing negative log of 0.000063. Okay, so I'm going to put that on my calculator. And I get that this is 4.2. So now looking at our ranges, 4.2 is going to put it here in our poor fin category. Okay, so I'm going to put it in that poor fin category. Now, another spot that this is used in, okay, is when we're talking about sound intensity, okay, when we talk about decibels, okay. So the number of decibels is 10 log I over I naught. Okay, now the I that they use in the book is more like this, okay, which makes it a little more difficult to read, so I'm going to do this. Now, they ask us to figure out if the intensity is 10,000 I naught, okay, what is that going to look like? So if we run that in, now what's going to happen here, first off, the I naughts are going to cancel off, okay, these are going to disappear. So now I've got 10 log 10,000. So plugging that in on our calculator, we get that that is, our decibels is 40. Okay? And 40 isn't terribly loud, okay? We have kind of things like hearing loss and stuff like that starts to happen up around like the 90, 95, 100 mark. Okay, so 40 really isn't too terribly loud when it's processing through. Okay, so now then, the other thing is, okay, we do not do log base E of X. Okay, first off, personally, I think that this E would start to creep up, and so we'd have log X. Okay, but this is L in X. Now you're going to see me do this in script. Okay, so I'm going to do script LNX, just so that you can tell that this is, because this can really look like a 1, okay, when that's processing through. So we want to make sure that it is actually an LN. So be very, 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 very careful with this. In my math lab, this is an LN. Now, the other thing is that this is called the natural log. Now, you may be looking at that going, hold on, NLLN, why is it backwards, okay? You got to realize that most of our math stuff came from Europe, okay? And when you think about a lot of those European languages, they kind of follow the same idea as Spanish, okay? Which is when your adjectives come after your nouns. So originally, okay, in their in the language that this was, you know, established in, this would have been like logarithm natural or something like that. So it made sense for them to abbreviate LN. When it translated over to English, the adjective came in front, so it was now natural log. And so it does look a little bit backwards to us. Now, looking at a couple of examples, I can do natural log of 142. This is that natural log button that is down here on your calculator. Okay, so natural log of 142. And this is going to be 4.956 roughly. Okay. And I did round that a little bit. Okay. So we can have all of those kind of same things where you're doing those values. Okay. Now, one of the things, okay, kind of an application of this is they look at, to figure out the age of a rock, okay, they measure the amount of potassium and argon that's in the rock, okay? And so the formula for this is kind of ugly looking, okay? But okay, now they ask how old is the rock if A is 0 and K is positive. Okay, now what's going to happen here, y'all, is if we plug in 0 into this thing, guys, 0 over K is just going to be 0. 8.33 times 0 is going to be 0. Natural log of 1 over natural log of 2. Okay, now I am going to do that division on my calculator. Natural log of 1. I am going to make sure that I close. Okay, so on my calculator, I'm doing natural log of 1, and I did close that, divided by natural log of 2. Okay, and we get that that is 0. So we now have 1.26 times 10 to the 9th times 0, which means that rock is not old at all. Okay. And that is probably because they're saying all of the argon is gone, and argon probably develops after the fact. Okay. Now, they then ask a separate question. Okay. If they say that A over K is 0.212. Okay. So kind of plugging this in, and I'm going to do a little bit of this. Okay, I'm going to do a little bit of kind of getting all of this together. So I'm going to do 1 plus 8.33 times our 0.212. And we get natural log of 2.76596. That is not rounded. And so now I'm going to put that in my calculator. Again, I'm letting the calculator take all of that. I do have natural log back up here at the beginning of the line. Okay, so I'm doing natural log of the first one. Notice that I'm closing that set of parentheses after that natural log and then moving on across. So now I have 1.26 times 10 to the 9th. And then this is 1.4677, and there's a bunch of stuff after this. Now, helpful hint on our calculator, okay? I can do this times 1.26, and guys, you have this little EE button, okay? It's right there with what is going to be the comma, and it's going to come up with that E, and like we talked about before, that E is your times 10 to the, so I'm going to now put 10 to the 9th, okay? And I get that that rock is 184,940,3169. So 1,000 million, it is roughly 1.849 billion years old. Okay, if we want to get technical on some decimaling there. Okay. So now, they talk about what's called radiative forcing, which is the carbon dioxide trapping the heat from the sun, okay? And the formula that they give for this, okay, looks like this, okay? Now then, they say if C is 2C0, they want to know, is this linear or logarithmic? Okay, so we're going to plug this in. So R equals K natural log of 2C0 over C0. Okay, and that's going to cross off. Now, you may be thinking about this going, oh, well, that's, it's going to be logarithmic because it has log. Guys, natural log of 2 is a number, okay? Natural log of 2 has a regular value. There's not a letter sitting in this, okay? So this actually winds up being 693 roughly. Okay, this is linear, okay? There is no log left in there. Now, it would be different if the K was inside of this over here, and then you would have to take the log of something in order to try and make that happen, okay? But that's not the case. Now, the next part of this that they give us, okay, is if T is a function of R, they want us to write T in terms of K. Now, first off, what we're going to do is we're going to solve this for R. So we're going to have T over 1.03 is equal to R. And now we're going to redo that up here in the top end. So we're going to have T over 1.03 equals K natural log C over C naught. Okay. And then we're just going to multiply that 1.03 back over to the other side. So now we have T in terms of K. And that's all they asked for that one. Okay, so now one of the other things that we talk about is called change of base. Now, the reason that we've got to talk about change of base is because oftentimes we are given a problem like log base 5 of 17. Our calculator cannot do log base 5. The only logs that I have are common log, which is base 10, and natural log, which is base E. So the formula that we use for change of base is going to be log base A of X is now log base B of X over log base B of A. Okay, now more commonly what we're going to see is log X over log A, because we're going to use common log, or natural log of X over natural log of A. Either way. So now, coming into this problem, this would now be, and I'm going to use common log, 17 divided by log 5. Now, do be careful sticking this onto your calculator. you need to make sure that you close that log of 17 before you go into that log 5. Okay? And I get 1.76 roughly. Okay? So there's our answer. Okay. Now, if they tell you to go more decimal places, then certainly go more decimal places, okay? I think this one actually said to go to 4, so this would actually go to, okay? Now, if they did something like log base 2 of 0.1, okay? And I'm going to do this one with natural log. So over natural log of 2, okay, so here we go. I'm going to bring this in. Natural log of 0.1 divide 2. Okay. And we're going to let that press there. And we're going to get, and again, I think they want 4 decimals, negative 3.3219. Okay. So there is that. Okay. So that is the end of section 4.4.